Good afternoon, viewers. Welcome back to Easy Mathematics. We thank God for another wonderful opportunity for me to come to you once again. This being our first video for the year and also for the academic term. Today, we want to start with a lesson in Basic 9, which is sets. Now, set is something new to us in JHS or in Basic 9, which happens to be a topic in secondary school for our seniors, but we have to treat sets. Now, what are sets? Now, in simple terms, sets are the square root of numbers that cannot be simplified into a whole or rational number. Now, we know that rational number is a number that can be written as a common fraction or a vulgar. So if we have the square root of a number and that number cannot be simplified, simple terms, it is a set. So if you look at the example, we have the square root of 10. Now, looking at the square root of 10, there's no way we can simplify it to get a whole number or to get a rational number. So because we cannot simplify the 10 happens to be a set. Now, when you look at the number, the square root of 4, looking at the number alone will tell you that 2 times 2 is 4, which means 2 is the answer. So 4 is not a set, but therefore 4 is a square number, which we've treated square numbers in our previous video in third term. So numbers like this are square numbers, but once it is in a square root, it will give you a whole number. So if it can give you a whole number, then that number is not a set. But once the number in the square root is not going to give you a whole number, then that number is a set. So to read the number, we say this is set 10. This is set 2. Set 15. So we don't say square root of 15, no. We say set 15. It is a set because the number in the square root cannot be simplified to get a whole number or a rational number. And this is read as the number in front set the number in it. So set 2, set 3. That is how we read set. So in simple terms, a set is a number that cannot be simplified when it is in a square root. Or numbers, sets are the square roots of numbers that cannot be simplified into a whole. Good. Now that we know sets, that they are the square root of numbers that cannot be written as a whole, let's look at some forms or types of sets. Now, set can be simple or compound. Now, with simple sets, we just have the normal set, that is the number in the square root. So an example is set 5 is a simple set. This is a simple set. Now, this is a set because the number in the square root cannot be written as a whole number. Then also, set 11. This is a simple set. 2 set 12 is a simple set. So simple sets are sets with only one set. Is that clear? Good. Then we also have compound set. A compound set is the combination of 2 or more simple sets. So if I have set 5 plus 2 set 3, this is a compound set. So 2 or more sets will give you compound sets. But a single set is a simple set. That is, it has only one set. But with a compound set, it has more than 2 sets. So you can give more example. 3 set 7 minus 4 set 3 plus set 5. So this is a what? A compound set. Just know what set is or what sets are, which will help you to understand. Now, once the number is in the square root and you can't find exact whole number, the word is you can't find a whole number for the number in the square root, then that number in the square root is said to be a surd. So examples are what we have given. Now, before we can simplify surds, before we can evaluate surds, we need to know the rules governing surd or the identities in surds. So let's quickly go through the rules for today. The next time we meet, we'll look at how to simplify surds. It is very, very important to know each rule, which is going to help you to solve or simplify any given surd. Now, the rule 1 is saying that when you have a square root times a number multiplying itself, here you can see that this is square root of a times a. Now, when you see something like this, it is the same or can be written as the square root of a times the square root of a. It is very, very important to know this, that if you have something like this, that the square root of a times a, remember the a that we are using is a variable. So if you know the rule, when we give you figures or values, you can be able to what? To simplify it. Looking at how the rule is being given and explained. So now, look at what we have. It says when you have the square root of a times a, it is the same as the square root of a times the square root of a. Now, we know in algebraic expression that any number times itself will give you the number squared. So the square root happens to be the same, which is given there, but the a times a will give you a squared. In algebraic expression, we were told this. Now, if this is a square root and this is squared, what happens to it? They cancel out. So this gives you a final answer as a, which means when you have the square root of 2 times 2, your answer is 2. So any number in a square root multiplying itself gives you the number. And this is the first rule, or the first thing you should know in this rule, that any number times itself in a square root is equal to the number. And it has been explained that if you have the square root of a times a, or if you also have the square root of a times the square root of a, it is the same as this expression. And a times a will give you a squared. But because it is in a square root, we need to break the square root. Then the square root will be cancelled out by the square, which is going to give you that. Also for this, whereby the numbers in a square root are different, it is going to give you the same thing, which is also the same as the square root of a times the square root of b. So this and this, they are the same. If this should come first, you can also write this. You can also write this as this. We can also say this is equal to the square root of ab, because in algebraic expression we were told that a times b is ab. A variable times another variable is the variable and that variable. So a times b in a square root will give us ab in a square root, which is the square root of ab. This is the first rule. You should know this rule so that when you are being asked to simplify sets, you can do the simplification. The rule 2 is also saying that when you have the square root of a number over another number, the square root of a number over another number, This square root is for the A, and the square root is also for the B. So now with this, it can also be written as the square root of A divided by the square root of B. Note that if you have the square root of A over B, it is not the same as this. This and this are not the same. With this one, the square root is only for the A, which is not affecting the B. But once the square root affects the B, also affecting the A, then you can write that as the square root of A over the square root of B, then you work out to get your answer, if we are being taught simplification of sets. So anytime you are being given the square root of A over B, know that this square root over A over B, the square root is for the numerator and it is also for the denominator. So I can also write this expression as set A over set B. Very, very important. That is what the second rule is saying. Then, if these are values that can be simplified, you simplify them to get your answer. Good. Now, the rule 3, or the third rule, is saying that when you have a question or a set given like this, whereby the denominator is a set, we are going to work out this in order to get the denominator to be a whole number. The denominator shouldn't be 0. So with this, our A should never be 0 when we are to work. And let's say we have values we are working for. So this is saying that when you have a set like this, we are going to multiply the numerator by the denominator and multiply the denominator also by the denominator, so that we can get rid of the square root. We don't want the square root to be at the denominator. So the third rule is saying that anytime you have something like this, multiply the numerator with the denominator and the denominator by itself. So this is the same as B times the square root of A, all divided by set A times set A. Now this set A times set A will therefore look like the first rule, which says that when a number multiplies itself, when a set multiplies itself, you are going to get a number. So here, B times set A will give you B set A, all divided by the square root of A times A. Now A times A, we know that A times A is A squared. So the square root can therefore cancel out the square. Now we have B set A all over A. And this is what the third rule is saying. That when you have the denominator to be in set, solve out the relation so that the denominator will no longer be in set, where the A should not be equal to 0. This is a new topic which, if you don't take it, you might find yourself struggling with it. But once you are able to understand the rule or the rules in this lesson, you can be able to simplify sets regardless how it is going to be given to you. So the rules are very, very important when it comes to sets. Know each of the rules so that you can be able to apply it in your simplification of sets. Let me go over quickly again. The third rule is saying that if you have something like this whereby the denominator is a set, we are going to write this in such a way that the denominator will no longer be in set, where denominator is also not equal to 0. To do this, multiply the denominator by the numerator and the denominator by itself. So when you look at this one, the denominator is set A. So we are multiplying the numerator by the denominator, which is the set A, and the denominator by the denominator, which is the set A. Now, anytime you have an expression like this, where a number is multiplying a set, or a variable is multiplying a set, you are going to get that number set. So B times set A is B set A. Then if you have set A times set A, the set A times set A can be written as the square root of A times A. And A times A will give you A squared. But since the A squared is in the square root will cancel out the square, or vice versa. Then you now have the A without a square root. And that is what the third rule is saying. Let us know the rules vividly, because it is very, very important. Now let's go to the fourth rule. Now the fourth rule is saying that whether you are adding or subtracting, so you see I've written A set C plus or minus B set C. So this, I can split it into two, which means A set C plus B set C. Also the same as A set C minus B set C. Now, when we are adding or subtracting sets, listen carefully. When we are adding or subtracting sets, the value in the square root must be the same. If the value in the square root that we are adding are the same, then we can do that simplification. So the value in this square root is C, and the value in this square root is also C. So if I want to add, I can add, or I'm going to add the coefficient of the sets. Now the coefficient of this is A, this is B. So I'm going to add A plus B, then I will pick one of the sets. It is just like you working with 2x plus 3x, whereby you are going to add 2 plus 3 and you say it's 5. Then you pick one of the x. It is more or less like that. But you notice that when you have 2x plus 3y, you cannot add this expression. You can't add this. So sets are more or less like what? Algebra. Let's say that. Since we are going to apply that here. So if the numbers in the square root, or if the sets are not the same, you can't add. And the addition is done by adding the coefficient of the set. And let me quickly go about the coefficient. Now the coefficient is the number in front of the set. So this number is 3. We say it is the coefficient of what? Of set 8. Now a set without a coefficient has the coefficient to be what? To be 1. Just like you having x. And it is being assumed that it has a spiritual 1. So a set without a coefficient is 1. It is very, very important to know. A set without a coefficient is 1. So here you have 3 set 8. The 3 is the coefficient. So when you come here and you are adding set, make sure that the sets are equal. They should be the same. So this is set C, set C. They are all the same. So just add the coefficient, which is A plus B. You put the A plus B together, then for the set, you pick 1. Now, if the sets are not the same, if they are not the same, we are going to work out to make sure they are the same, which we will talk about that if God permit, in our next lesson. The same thing happens to the subtraction. If you are subtracting, the sets must be the same. If the sets are the same, you can carry on with the subtraction. So here, what are we subtracting? The coefficients. So we are going to say A minus B, then we pick one of the set. Why do we pick one of the set? Because the sets are equal. Because they are equal. If they are not equal, you cannot perform the operation. Just like the one I did and claimed. That is what the fourth rule is saying. Let's take good note of the rules. They are very, very important. Now the fifth rule is more or less like the third rule, whereby we don't want the denominator to have a square root. But it says that if you have C over A plus B set n, multiply with the opposite of the denominator, the opposite sign. So if this is addition, we will multiply the numerator with the same expression, but this time negative. So we are going to say C times A plus, we are going to multiply the numerator by the inverse of the denominator. So instead of addition, we will multiply with subtraction. So we are going to say C times this A minus B set n all over this denominator, which is A plus B set n, times A minus B set n. Then you do the calculation. The fifth rule says that if you have an expression like this, where you have compound sets, you see this is a simple set. So we just multiply the numerator by the simple sets, denominator by the simple set. But here we have the denominator to be a compound set. Now, once you are having this, the rule is saying that multiply the numerator by this denominator, but the sign should be changed to negative. So if I'm going to multiply this by the numerator, instead of writing addition, I will change it to subtraction. Then I will multiply the denominator also by the same thing here. Then I do the multiplication. So let's take our time here and do the multiplication. Now, let's work for the numerator. Working for the numerator, you know that we multiply this times this. So C times A will give you AC. Then C will multiply negative B set n, which is negative BC set n. If you take your time to multiply, you know this is just like you multiplying using the distributive property, as in 3 times 2x plus 3y. So this will multiply this. This again will multiply this. It's the same thing. So C multiplying A, C again multiplying negative B set n. So now that we are done with the numerator, let us also do for the denominator. Now with the denominator, it is 2 binomials. 2 binomials. Now the A will multiply everything, and this B set n will also multiply everything. So let's get the expression. So we have A bracket of A minus B set n. Then we have plus B set n bracket of A minus B set n. So the A is multiplying everything, as you can see. Then the B set n is also multiplying everything. So let's take our time here. We are going to get the numerator is AC minus BC set n divided by the denominator. So A multiplying A will give us A squared minus AB set N will give us AB set N. Then B set N times A will give us plus AB set N. Then B minus B set N. So B times B is B squared. And set N times set N is N. So this is going to give you B squared minus B squared N. Because B times B is B squared. Then when this N squared multiplies this. So what we have there, let me quickly write it here. What we have there is B set N bracket of A minus B set N. So this will multiply this, will give you AB set N. Remember, we said that when a number multiplies a set, you have the number set. Here too, a number is being multiplied by this. So we are going to multiply the coefficient of the set times the number. So B times A is AB set N. Then we have minus B times B is B squared. And set N times set N will give you N. Because numbers in the square root multiplying, if they are the same, gives you the number. So the expression for that is going to be this. AB set N minus B squared N. Now when you look at the middle terms, you can see that positive AB and negative AB set N will cancel out. So you have the expression as AC minus BC set N, all divided by A squared minus B squared N. And this becomes your answer if you are to work with values. Now, the root C is more or less like the root 5. But this time, this is negative. So you are going to multiply this with a positive 1. So you do the C as an assignment. Then you drop it in the comment section for us to assess your seriousness. So just follow how we've done the 5. How did we do it? The root 5 is saying that, quickly let's go over. When you have an expression like this, multiply the numerator by the denominator, but change the positive to negative, to the opposite side. So if this was negative, this is going to be what? Positive. But this is positive. So we are going to multiply with the negative. Good. So now you have C times the same thing, but the sign becomes the opposite. Then this times the same thing, but the sign becomes negative. So this multiplying this will give you AC. Then C multiplying this will give you BC set N. Now when you come to the denominator, we have two binomials, which soon we will look at algebraic expression in basic 8. Now, two binomials, simply, we are going to use the A to multiply this bracket. The A will multiply this bracket. Then the B set N will multiply also this bracket. So now, if A is multiplying this bracket and the B set N, the sign is positive, so it has to be in front. It's also multiplying this bracket. Then A times A will give you A squared. Then A minus B set N will give you minus AB set N. Then B set N A will also give you AB set N, which is this one. Then you have B set N times negative B set N. The sign becomes negative. Now B times B is B squared. Set N times set N will give you N because of this rule. It says if you have a number square, the square root of a number times the same number in a square root should give you the number. So square root or set n times set n will give you n. Simplifying will give you this as your answer. And these are the rules in sets. Basics, the introduction. These are the what? The common rules that we need to know in sets. That the moment the rules are well known, we can simplify sets. We should just take note of that. Now, here you were given positive, so we multiplied with negative. Here you have been given negative, so let us do this as an assignment. You can also drop your answer to our WhatsApp number 025-703-8171. We will respond to you. We are ready for you to understand mathematics very simple and easy, or at ease. You can solve, drop your answer, and we promise to let all viewers and subscribers know the one who was able to get it correct. Thank you very much. Today we've looked at the introduction of set. We said sets are the square root of numbers that cannot be simplified into a whole. So if it is in a square root and you cannot simplify it, then it is a set. So we've given examples. We said we have set 10. So we don't say square root of 10, no. And I said it is read as set 10, set 2, set 15, 2, set 3, and so on and so forth. We said we have simple sets, that is set with single or values with single sets, and we have compound sets, that is the combination of two or more simple sets. And we've looked at the rules, we have explained them vividly, which of course will help you to understand the rules of set. That will also help you in simplification of set. This is basic 9 lesson for the 10, which we are preparing for the BEC or the standardized test ahead of us based on the new curriculum. We will meet again, but we'll treat a lesson in basic 8 after we give you the continuation of the sets, that is simplification of set. See you next time. Don't forget to hit the subscription button. Please share. You can also sponsor this program. We need sponsorship so that this program can also be well known and will provide you with the quality of videos and other things. Sponsor this program. You can be a shareholder once we are able to sit and have a conversation on your sponsorship and what you want to do for this service. Sponsorships are needed. Sponsor this program, share, hit the subscription button, and also tell a friend to tell another friend to come and also be educated. The name is Christian Malku Jokwe. See you next time. Bye bye.